Hello students, welcome back to the next module. We'll continue with numericals on energy in SHM. So let's start with our first numerical. A particle executes SHM with a period 8 seconds. Find the time in which half the total energy is potential. So let's write down the given part, students. As we see, time period is equal to 8 seconds. So we write here capital T is equal to 8 seconds. The next given is half the total energy is potential. That means potential energy is half of total energy. To find is time, that is instantaneous time, small t. So we have to find time here. The required formula. So the first formula that we are going to use is potential energy, which is half Ka square. Of course, total energy, which is half Ka square. Students, to find this t, as I have already told in the earlier modules, whenever we have to find small t in this chapter, we have to use the formula of displacement equation, that is x is equal to a sine omega t plus alpha. Omega is not given here, so we have to use the formula omega is equal to 2 pi by t. So let's start with the solution, students. So we'll start with the given hint first. So as it is given, potential energy is half of total energy. Let's write down the respective formulas on both the sides and we get half Kx square is half of half Ka square. Let's cancel half K from both the sides and therefore we get x square is equal to a square upon 2. Taking square root on both sides, we get x is equal to a upon root 2. So potential energy is half of total energy at a displacement a upon root 2. Let's calculate omega now. As we know, omega is 2 pi by t and t here is 8 seconds. So 2 pi upon 8, 2 4s are 8 and therefore students, omega is equal to pi by 4 radian per second. Now let's go for the displacement equation. As we know, x is a sine omega t plus alpha, that alpha is equal to 0 and hence x becomes a sine omega t. Let's substitute the respective values here. So x is a by root 2 into, that is equal to a into sine of omega t. Let's cancel a from both the sides and hence omega t becomes sine inverse of 1 upon root 2. We know from trigonometry sine of pi by 4 is 1 by root 2 and hence I can write omega t is equal to pi by 4. Now we will substitute the value of omega, which is pi by 4 into small t is equal to pi by 4. I can cancel pi by 4 from both the sides. Therefore students, the required time in this numerical is 1 second. So from the given hint, we found out the value of x. Then by using the formula of x as a sine omega t plus alpha, we found out the value of t, which is equal to 1 second. Let's move ahead with the second numerical, students. The total energy of a simple harmonic oscillator is given as 3 into 10 raised to minus 5 joules and the maximum force acting on the particle is 1.5 into 10 raised to minus 3 Newton. Write down the equation of motion of the body if the period is 2 seconds and the initial phase is 60 degree. So the given total energy is given as 3 into 10 raised to minus 5 joule. Maximum force is 1.5 into 10 raised to minus 3 Newton. Also time period is given to us as 2 seconds and initial phase as 60 degree, which is to be written in radians as pi by 3 radians. To find this equation of motion, that is nothing but the formula of x. So let's write down x with these terms available. Now formula. First of all, total energy half m omega square a square. Students, I need F max. We know F is equal to MA. Now since M is always, M will not change at all. So F max will become M into A max. But in SHM, A max is A omega square. Therefore, F max will become, students, M omega square A. Let us write down it here. So F max is M omega square A. Now as we have to find the formula for x here. So x we have to use as x is equal to a sine omega t plus alpha and we'll also use omega is equal to 2 pi by t. So let's start with the solution, students. So to begin with, we know total energy is half m omega square a square, say equation 1. F max is m omega square a, say equation 2. In dividing equation by equation 2, we get T upon F max is half m omega square a square upon m omega square a. Let's cancel m. Let's cancel omega square. Let's cancel a, and 1a is in the numerator now. Therefore, next step, Te upon F max is half a. So students, from here I can get the value of a as it is twice into, so it becomes twice into total energy upon F max. Now we'll substitute the value of total energy and maximum force. So the next step becomes a is equal to 2 into 3 into 10 raised to minus 5 upon 1.5 into 10 raised to minus 3. 1.5 into 2 is 3. Also, if I take that minus 3 in the numerator, it will become 10 raised to 3, and therefore overall answer becomes, that is a is equal to 4 into 10 raised to minus 2 meter, and which can be expressed as a amplitude is 4 centimeter. Omega will become 2 pi by t, t is equal to 2, and omega becomes pi radian per second. Now, as we know, equation of SHM is x is equal to a sin omega t plus alpha. Let's substitute the value of a, omega and alpha here. So our answer finally becomes x is equal to 4 sin pi t plus pi by 3 centimeter. That's all in this module, students. See you in the next one.